And hello, welcome back YouTube. Yes, welcome back to our FreeCAD and Salome multi-region meshing with OpenFoam. So we are back to our construction of shapes in Salome. So as you can see, there are some things we needed to construct. Okay, there's some things we needed to construct. So these are actually the sub-shapes of these regions, so that we need to make our complex shape as I was talking about earlier. Alright, so I'm just gonna continue where I left off the last video. Okay, so we actually make the inner tube already, so that's fine, that's great. Alright, so next thing we need to do is to make the copper bit. We're going to repeat the same procedure over and over again. So I'm going to hide the tube bit. I'm going to show the copper N1, okay, copper N1, copper N2, and of course I need to actually show this part called what is that, tube to copper. So tube to copper. So these three shapes will be there, and I need to make one additional shape to make the tube portion, the copper portion, which is this pipe layering between the shell side and the tube side. So there'll be a region of copper, or whatever material you want to put there. I'll just use copper. Okay, so the copper is over here, the copper region is here, and again we will need to do the same thing. We need new entity. Alright, we need a new entity here from the copper N2. So let's do this. We'll create a new group, and we'll create H. The shape type will be H, and okay, copper N2H will be the name, and the copper N2 will be the main shape. And I'll just select this outer shape here. I'll add and apply. Then I'll do a copper N1H. So this will be the main shape. Copper N1. Okay, copper N1. Okay, come on. Oops, sorry. Maybe I'll just select the other side. Okay, I'll select copper N1 here, and I'll just put new entity, group, create group, and I will select this H. So copper N1H will be the shape name, and I will select this outer H and I'll add it in, and I'll just apply. So let's see whether I got it right. Copper N1H and copper N2H. Alright, so copper N1 and copper N2 will be there. And where is my tube to copper butt? So that will be it. So I will have a shell to copper surface, which will be the outer surface. Alright, so I'll make the surface generation again. So I mean, doing it repetitively does help it stick in the mind. Alright, so copper NH1 and copper NH2, I will make a new entity under generation, new entity generation. Then we will go to filling, and then we'll call this filling copper or tube, shell to copper. Alright, shell to copper, and the input contours will be these two shapes here. And you can see the outer shape has been made, and I'll just click apply. And again, we'll have the same old story. We're going to use these four surfaces to create a solid. So that solid will be called copper. Okay, so shell to copper, tube to copper. Okay, select these four surfaces, copper N2 and copper N1, and I'll make a new entity. Okay, I will build a solid, and the solid will be here from these four ends, copper N1, copper N2. Remember, I'm holding the control down as I'm clicking so that I can, select multiple. I will intersect and sew the shapes, and I'll click OK. And I will name this region copper. Okay, it's pretty simple. So our copper will be this solid here, this ring hollow cylinder, so to speak. This will be the hollow cylinder, which is copper. I mean, this copper pipe is like that. And just to check, tube will be the inner part. So that is that. Okay, so now we'll have to do the exact same thing for the third region. Alright, good thing though, for the third region, you won't have to make any new surfaces because all of them are already there. So shell to copper, and let's look at the inlet shell, outlet shell. Any shape to do with a shell, we'll need to select. Shell N2, copper N2, blah, shell N1. We'll look for any shape that has to do with a shell. And if you take a look, the shell has already been so nicely selected for us. Okay, because I mean, this is the last interface. We don't really need to do anything more. So this is the shell shape. Okay, shell shape. All right. So a little bit of pronunciation thingamajig there. Right. So now we'll have to do the new entity. Okay. Again, I'll build the surface. Remember, this time we already built our faces to make complete set of surfaces. So now we just need to fill in those fill in to make the new solid. So solid is here, and again I will name this solid. This time I will put the result name to be called shell. Okay, I'll intersect and sew the shapes, and I will make these objects. Okay, curved shell surface, shell N1. Okay, shell N2. Inlet shell curved, outlet shell curved, inlet shell and outlet shell, and of course the shell to copper. Everything else should not be selected. These are 8 shapes which I apply and sew, and I will have my shell shape. So let's see whether this shape is correct. Okay, I mean, it looks legit to me. Excuse me, it looks pretty legit. Yeah, it looks legitimate to me. Alright, so that is how we make our shell shape. So let's do a final check before we go on to our next step. So we have the tube, we have the shell to copper, which we don't need. Actually, you just have tube, copper, and shell. And then you'll see these 3 regions actually being shown to us. Okay. So now the thing is, how do we then get all of these shapes into one shape so that we can make the complex shape? Okay. So next thing we need to do is to sort of merge these shapes, and they will come under this step called partition. Alright. So I'm going to select these 3 shapes, the tube, the shell, and the copper, and I'll go to this part called partition. Alright. Or we can actually make a compound, but okay. The way that was shown to me by Ali's tutorial was to use the partition command. So I'll just use this thing called partition. So click partition, and this partition will be so-called the fusion of 3 objects. Okay, so I'll just call this heat exchanger. Alright, one pipe heat exchanger, because all it is just one pipe basically. Alright, so I'll have apply this, and look at this. This new complex shape actually has the tube, copper, and shell there. Alright, so now we'll need to make all the patches and the faces, and of course the individual zones for the individual solids, sub-solids under this one pipe heat exchanger, so that we see what we have in the last video. So that has to happen before we start meshing. So we need to split up the regions, and we need to split up the patches. Alright, so next thing we need to do, okay, we need to sort of have this thing called new entity. I'm going to create group. We're going to have solid, or actually maybe it's easier to just explode, okay, into the individual subshapes. Okay, so let's see what this does. Alright, new entity, we're going to explode this compound shape into the individual solids, and you just click apply. So you see that yeah, we see that once we construct this complex solid from the components, we are able to explode this up into solids, not just faces, so that you have your subregions here. And remember, these subregions must be listed as part of this compound solid. So you see, this is the compound solid, this is the solid 1, solid 2, and solid 3, which are the subregions, so to speak. So what are and you can see that they are sort of subregions because this compound solid, right? This compound solid is over like more indented to the left, and all of these are slightly more indented to the right. So that's the idea you want to have here. Okay, so next thing. So what are these solids? You can just click the eye icon and you'll see that solid 1 is actually the tube side. So we'll call this a tube. Solid 2 is the shell, copper. And solid 3 is actually the shell. Okay, not a big problem there. Okay, so we will then need to do individual faces. Okay, so this again we can use the explode command. So new entity, we can actually do this explode. We can look for face. So we'll explode all of these patches into individual faces, and we'll just click apply. And what will you see? You will see all these individual faces actually come up. So again, we'll need to go through our naming convention. So I'm gonna hide all of this. Okay, I'm gonna hide all of this, and the names of these faces will become our patch names. So let's see maybe the tube side, and let's compare. Okay, so this is obviously part of the shell. Okay, if you see face 1, this is actually part of the shell. This is actually the curved shell surface, curved outer shell. Okay, so there's a curved outer shell surface, right? So this is what it looks like. So what is this? This is actually like the end of the shell that's in the origin. So that's phase 2. So I'll call this is it shell N1 or shell N2? Excuse me. So let's see, tube N1 is here. Tube N1 is closer to the origin, so I'll call this shell N1. Shell N1. Okay, so this will help name the patches once it's brought over to OpenFoam. So this is the outer shell. Okay, phase 3 will be tube N1, as you can see. Tube N1. Alright, all the N1s will be closer to the origin. Okay, so this one will be copper N1. Copper N1. Alright, copper N1 is there. Okay, what's phase 5? Phase 5 is actually, we'll just call it tube to copper. Tube to copper. Okay, next thing is phase 6, which is shell to copper. So let's call this shell to copper. Alright, phase 7. Okay, so this is actually the shell N2. Because this was shell N1, we'll call this shell N2. Shell N2. Okay, what's phase 8? Phase 8 is actually the other end of the tube. So this is called tube N2. Alright, so this is tube N2. Phase 9, we'll call this copper N2. These are just the naming conventions. Alright, so once we're done with this, phase 10, 11, 12, and 13 are basically the same. Phase 10, what is phase 10? What did we name this before? These are one of the edges. Alright, so as you can see, this is actually the inlet shell curved. We call this the inlet shell curve part. So that is actually phase 10. So you can check. Okay, I can see where inlet shell curve is. It's over here. And I can turn it off, and let's see what phase 10 is. Again, it's the same. So I'll call this inlet shell curved. Inlet shell curved. Okay, so that's where the inlet is. Phase 11, outlet shell curved. Okay, phase 12, inlet of the shell. And phase 13, outlet shell. And basically we are done. We just use the explode 2 times on this compound shape, and all of these faces were generated for us, no problem. Okay, so now we have our nice compound shape. We can start to do meshing. So let's go to the mesh module, keeping in mind that this is the shape that we want to mesh. This one pipe heat exchanger, which has this which is this compound shape of this tube, copper and shell, right? And then you have all these sub-regions here, tube, copper and shell, and then you have all these surfaces named out nicely for you. All right, so once you do that, go to mesh. Okay, go to the mesh module, and what you do is under mesh, go and click create mesh, and I'll just do the automatic tetrahedralization here. I'm not gonna do too much because this should be a very simple geometry, right? I just want to demonstrate how to make the multi-region mesh. I'm not going to add boundary layers or anything, just for simplicity's sake. So this is our mesh, and we'll just need to do compute. So it should compute pretty quickly because it's a very simple mesh. We see that there are about 20,000 tetrahedrons, 20,000 volumes there, and this is what our heat exchanger looks like. Okay, and to check if you are on the right track, look at the groups of faces. You should be able to see all these individual faces here. Okay, the copper ends, the shell ends, everything, all of this should be here for you to see. Alright, and if you're satisfied with this, and I am satisfied, I think this should be okay. Okay, I'm gonna hide everything, and I also want to take a look at the groups of volumes. So the tube should be inside, the shell should be on the outside, and the copper should be in the middle. If you have all of these under your mesh, then you are generally on the right track. So I'll call this one pipe heat exchanger. Okay, so once you check that all these faces show up and all these volumes show up, and you are generally now ready to export it as a UNV file. So I'm going to right click this, and I will see, okay, exporting isn't here. Oh yes, exporting is here. Export this mesh as a UNV file. So I'll search for the OpenFoam directory. I'll look for the OpenFoam directory under CHT multi-region foam, and I'll go to heat exchangers, and I'll just do this. Okay, I will save over this file, CHT one pipe heat exchanger. So I'll save over this file and overwrite it. Okay, oops, yeah, I'll save over it because those should be almost identical. So once I do this, I can do ideasUnVToFoam of CHT blah blah blah, and all of this, it should not give you an issue here, right? Should not give you any problem. And we can touch heat exchanger.foam. Alright, and that I'm going to delete this. I'm going to just do heat exchanger.foam. Again, you should be able to see all of this coming out nicely. Alright, you will see, of course, all these mesh regions, but they are not yet split into the various regions yet. And of course, if you take a look at the axis grid, this is actually pretty huge. This is actually 20 meters. This is not, or 200 meters rather. This is not 200 mm. So I'll need to scale it down as well. So what I'll do is just do a transform points scale 0.001. Okay, I spelled transform wrongly. Okay, not the most ideal of cases, but okay, so you'll have this transform points. So I will redo this, and you'll see that this thing has shrunk. it has shrunk. You see the axis grid. Now look at this thing. Now it has shrunk by okay, my time's almost up. So it has shrunk by 1,000 times. And next thing we'll need to do is to split mesh regions. Split mesh regions, cell zones, because all of these you can look at this. We have a face and cell zones. Face and cell zones. You have the shell zone, copper zone, and the tube zone. So I need to split it up by cell zones, and of course I'll just do the overwrite to overwrite the polymesh file, and I'll delete and open again. Of course I can press F5 to do the reload process, but I don't really want to. Alright, so doing so, you will have your multi-region mesh ready for you to set up your case. So you'll still need to do your constant system FE solution. All of these files will need to be configured before you start running. Alright, so this is the most basic of basic key exchanges you can get. It's a basic multi-region case. Okay, so this is a Salome FreeCAD for you. What else? Yeah, so most basic of cases, we'll need to assign boundary conditions to each patch, FE solutions, FE schemes, blah blah blah. That's all in the next few videos. But you can see it's a little bit more complex to prepare multi-region meshes, but once you get the hang of it and you see how repetitive it can get, it should be easier for you. So hopefully this clears up some confusion. Thanks for watching. I'll see you guys again. Bye bye.